Question 4a, f of x is equal to x to the fourth minus 8x squared. And we want to see where's f of x increasing, decreasing, concave up, concave down, etc. Okay, so we'll start with information that we can learn about f of x from the function itself, from f of x itself. So let's factor f of x. So f of x is equal to x squared times x squared minus 8, and this we can factor that into x minus square root 8 times x plus square root 8, and we do that so that we can see that the zeros of f of x, which are the same as the x-intercepts, are found at x equals 0. That we get from factor x squared at x equal square root of 8 and at x equal minus square root 8. Okay, so these are the x-intercepts. And since x equals 0 is an x-intercept, that means that f of x goes to 0, 0. So that's also a y-intercept. Okay, so 0, 0 is an x and y-intercept. Now let's look at the end behavior. Alright, so we want to know what's the limit as x goes to infinity of f of x. Well, we can just take the leading term, that's x to the fourth, and that's equal to infinity. In fact, that's equal to infinity since 4 is even. The limit is infinity when x goes to plus infinity or minus infinity. X to the fourth will go to positive infinity. So this function goes up to infinity on the right and on the left, all the way on the right and all the way on the left. Okay, now f prime of x, let's take the derivative. Okay. F prime of x is equal to, let's see, 4x cubed minus 16x. And let's factor out 4x. And that's equal to x squared. 4x. Wait 1 second. Okay, that's 4x times x squared minus 4. Alright, so we can factor that further, and so that's 4x. X plus 2, x minus 2. So now and then if we set that equal to 0 in order to get the critical values, or the places where f prime is equal to 0 or does not exist, we see that these occur at x equals 0, 2, and minus 2. 0, minus 2 from this factor, and 2 from this factor. So we'll put those on the number line in order. Okay, minus 2 on the left, then comes 0, then comes 2, and we do our plus minus analysis. So if we plug in something all the way on the right, like 3, we'll see that everything is positive, 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 positive. And plug in 1. In between here we have negative, positive, positive, so that's negative. And if we go ahead like this, we'll see that f prime is positive in this interval and negative to the left of minus 2. So that means that our function f is decreasing on this interval between minus infinity and minus 2, increasing from minus 2 to 0, decreasing from 0 to 2, and increasing to the right of 2. And right here we have a min at minus 2, a max at 0, 0, and a min at 2. If we substitute minus 2 into our function, into f of x, okay, then we have the following. Minus 2 minus 16. Okay, substitute 0 into f of x. We have 0, 0. And here we have 2 minus 16. Again, this minus 16, that comes from substituting the x value into f. Alright, so let's just see over here, this is 2 to the 4th, that's 16 minus 8. 2 squared, 8 times 4, 16 minus 32. 16 minus 32, and that's equal to minus 16. Okay. Alright, so that's all the information that we get from f prime. And now we're going to go to f double prime. Okay. F double prime of x, okay, looking at f prime over here. Okay, we take this, and so f double prime of x is 3 times 4, that's 12, x squared minus 16. So let's write that down. So we have 12x squared minus 16. And just factor out, we can factor out 4. So that's 4 times 3x squared minus 4. So let's set this factor equal to 0, 3x squared minus 4 equal to 0. So we have 3x squared equal to 4, or x squared is equal to 4/3, or x is equal to plus or minus the square root of 4 is 2 over the square root of 3. So those are our places where f double prime is 0. And let's do a plus minus analysis now on f double prime, placing the zeros of f double prime on the number line. Here's minus 2 over root 3, and here's 2 over root 3. And again, to substitute into f double prime, let's say we substitute in something bigger than 2 over root 3. 2 over root 3 is about 2 over 1.7, which is a little bigger than 1. So let's put in 2, for example. So if we substitute in 2, we have 12 times 4, that's 48 minus 16, that's positive. And let's say in between these two values we have 0, substitute in 0, we get minus 16, that's negative. And if we substitute in minus 2, we'll have a positive value. Alright, so that's our plus minus analysis, and that tells us that f is concave up on this interval between minus infinity and this value, minus 2 over root 3. Okay, concave down here in the middle, and concave up on the right. Alright, and that tells us that we have an inflection point, 2 inflection points actually. because the curve is changing its concavity from up to down over here. So this is an inflection. And from down to up here, so this is also an inflection. And we can substitute these values into f, and we have the y value of minus 80 over 9. And here as well the same y value, and really that's because our function f is an even function. So f of x and f of minus x are equal. That's why we get the same value here and here. Okay, here's x, here's minus x. Okay, and they have the same y coordinate. Okay, so that's all the information we have about our function. And now we can start filling in our graph. So let's do that. So here's our graph. Let's see. Well, we have intercepts 0, 0, the square root of 8, and minus the square root of 8. So these are x-intercepts. Okay. And we have end behavior. We know our function is going up on the right and up on the left. We also know that 0, 0 is a max, so I'll draw it like a max. Let's put in our two minimums. We have a minimum at 2, at 2 minus 16. Okay, so let's say here. Let's say this is around here. If this is 2, say. And here we have a minimum. And another one at minus 2. Minus 16. And then in between here and here we have an inflection. So the inflection is at 2 over root 3 and minus 2 over root 3. So here we have our inflection. Oops. Right about here and here. Where the curve changes from concave down to up. See? Here. We see down and then to up. That's what's happening here. Concave down to up. Now on the other side, up to down. And then just see, we have to connect this with that intercept. And on the other side as well, connect it up with the intercept. Okay, and that's the graph.